Okay, let's see. What are we looking at? We're asked to graph and compare this graph to f of x equals x squared, which is our parent function. So we're given p of x squared minus 3. So what we're kind of getting into now is tagging along a number at the end, adding or subtracting. So this really is the parent function. Look, it's the same thing. But then we got this minus 3 at the end. So at this point, our parabolas are still going to be centered on the y-axis. It's not until we get a single x term that we're going to get the potential for shifting left and right. So we're going to use a table here and just plug some numbers in. -2 to 2 is a great plan. That'll fit everything around here. And I'm just going to type these numbers in. Now, because I'm squaring, it's really important that I put this -2 in parentheses, that the thing gets squared, and I don't just do -2 squared on its own. It doesn't seem particularly focused. That's a little better there. And then we're going to do -3. So I'm going to get -1. Now here, I'll show you. If I just do -2 squared minus 3, you're going to get a different answer. This second one is incorrect. This first one is correct. And the difference is, hopefully what you're seeing here, is the fact that the negative is included in the squaring. So those parentheses do matter. Bring up the correct one again. All right, so we should have 1. Now let's change that -2 to a -1. We're going to get -2. Let's change it to a 0. I'm going to delete, which is the del button, the delete button. And then I'll change that 1 to a 0. We get -3. We'll bring it back up. And again, on the blue computers or calculators used in class, you can just immediately start using the arrows to overtype. So let's change that to a 1. I have to pull mine back up. There we go. We'll change it to a 2. My input here is 2. And I'm going to get 1. All right, so I got coordinates that I can go ahead and graph. Well, let's see. -2, 1. So I'm going to go from the origin, I'm going to go to the left 2 because my x-axis is -2 and up 1. At -1, I'm going to go down 2, so I'm here. At 0, I'm down at -3. At 1, I am at -2. And at 2, I am up at 1. So this is giving me a nice little parabola with a low value here at -3. And let's see, I can kind of connect it this way. And clearly this thing could continue growing up in both directions. So that's the graph. That's the first part. We did this, right? Check. Now we want to compare it to the parent function. Now the parent function is this guy, f of x equals x squared. Oh, that's not the one that I wanted. I thought I had a parent function graph. Handy. I do. There it is. You can't see me running off frame to my other table. Here it is, f of x equals x squared. This is the part I want to focus on. Vertex centered at the origin. The growth is to the left and right 1, up 1, because 1 squared is 1. To the left and right 2, up 4. Real numbers for the domain, the range, everything above 0. Axis of symmetry right down the middle. We have a lot of that happening here. The only thing that's happened is the parent function would be centered here at the vertex. And it has shifted down 3. But to the left and right, we're still going up 1, right and left 1, up 1, right and left 2, up 4. There is no stretch, shrink, or reflection, and that is because the multiplier out here is 1. So really the only thing that has happened on this guy as far as relative to the parent function is that we have a shift down 3 units, making the vertex at 0, -3. That does change the domain and range a little bit. On the parent function, the domain is all real numbers and the range is everything above 0. It's going to stay the same for the domain because these arrows are forever going left and right as they go up. So our domain is still going to be all real numbers. But the range actually now has a different low point. The low point is now -3 and it's everything above that. So we can do y is all real numbers, but y has to be greater than or equal to -3. We graphed it. We compared it to the parent function. I also added the domain and range. We can talk about the axis of symmetry too, just really briefly here. I can put that on there. It's right down the middle. Axis of symmetry always goes through the vertex. So if I wanted to add that on here, axis of symmetry. It is the vertical line, so it's always going to be x equals a number, and it's going through 0 there at the vertex. It equals 0. All right, I hope that is helpful. Message me anytime you have questions.